there's a general sense that we need to know more about what's happening above the Arctic Circle, and this is a region that we have very few direct measurements.
3, 2, 1, go. Away.
What we're doing here has two objectives. Number one is to support ESA in preparing for a launch of Aeolus, which is a wind measuring instrument. Our second objective is a polar winds science mission where we're trying to validate models that are designed to tell us what's happening near the surface of the ice of Greenland in particular.
My name is Wayne Ringelberg. I am the aircraft commander for today's sortie and the senior rep on deployment for the DC-8. When you're chasing things like winds, they're fairly dynamic phenomena, so there's a lot of times when the objectives will change or the area that they're wanting to look at is moved based off of what they're seeing, and we have to try and make that happen in real time. That can be a challenge flying in the airspace we're in, because in and around Greenland it's a non-radar environment, which means that we're having to relay our position over the radio.
The DC-8 is an excellent scientific platform for a number of reasons. It's a 4-engine airplane. It's been re-engined with the CFM56. It has plenty of power, fly long distances. It's got a big wing that's swept a little bit less than some of the other airplanes. It's also extremely structurally robust, so it's relatively easy to do structural modifications without affecting the airworthiness.
We're going to do 12,000 feet minimum altitude for all route unless you cut these short. Okay, because there's a 9,200 foot peak right where that.
4 wind lidars. To my knowledge, I've been in this for over 30 years. To my knowledge, this is the first time ever that we've had 4 wind lidars flying in formation.
The Dawn lidar is a Doppler aerosol wind lidar. What it does, it looks at the small particles in the air, be it dust, ice, water droplets, what have you, to measure the wind. And it uses infrared eye-safe laser to measure those winds.
Twilight instrument is a molecular Doppler lidar. Basically, it's a complementary instrument to the Dawn, which is an aerosol instrument, and gets very high precision when there are aerosols to scatter off of. Twilight has less precision, but a very predictable signal because it scatters directly off the molecules themselves.
3, 2, 1, drop.
And a drop sonde is a small package of instrumentation that we drop out of the aircraft.
2, 1, go.
So we get wind speed, wind direction, temperature, humidity, pressure, and surface temperature. The lasers, the 2 lasers we have, are telling us winds and aerosols and clouds, but we need to know the temperature for us to correct those observations and adjust those observations.
So we have a lot of opinions on what's happening out there, and our job here, at least my mission, is to take measurements where we can go back and validate those models and improve them. But this is a great opportunity for us to see how these different technologies measure winds.